To the question first though, what in the world is a piecewise function? If you went through our Algebra 2 class last year, then this should be familiar, but some students, when we get to pre-calc, have not seen this before. This is the idea of a piecewise function. It is a function. That means it passes a vertical line test. You can't cross twice for a vertical line, and you're in pieces. This one has 3 pieces to it. So lots of times that means there's going to be a jump. Not always, but often there'll be some type of jump discontinuity going on with piecewise functions. So we're going to graph them and come up with equations and all that fun stuff. The first thing on our example, for example 1, is to see that these, what do we say this? This piece here, this negative x squared minus 2x plus 8, has a very specific domain. It only exists when x is less than or equal to negative 3. Okay, so every one of these pieces has its own domain, and this is where the domain is given. So I try to graph this just to kind of show you what a visual representation is of this. You don't have to graph these, but what we're doing is evaluating. We're going to plug in a negative 1. So the question is, which of these 3 pieces do we plug it into? We plug it in. Negative 1 is in between, it's this x value right there. It's in between negative 2 and 5, therefore we plug it into this. So we'll go 3 times negative 1 plus a negative 1 cubed, and you work this out, you get negative 3 minus 3, which, negative 3 minus 1, excuse me, negative 3 minus 1, which is a negative 4. Which, by the way, if I ever make a mistake and I write down the wrong answer, feel free to comment that below in the comments, because I hate having wrong answers up here and not finding out about it for a month. How about f of 5? This means x is a 5. Let's plug in a 5. Is it this piece? No. This piece? No, because it's less than 5. This piece? Yes, because it's greater than or equal to 5. So we'll work that out real quick. We have the absolute value of x, not x, sorry, 5 minus 8. And then that means we have the negative absolute value. 5 minus 8 is negative 3. And then we have negative, the absolute value of negative 3 is 3. So this is negative 3. Now, before I go to the next one, let me show you on the graph. X is negative 1, y is negative 4. So if you come out here on the graph, this is going all the way out to negative 9. So if we come out about negative 1 and go down, you can see that right there is where that point is. Now the scale here is pretty big, counting by 20, so you can kind of get an idea. How about 5? If we go out to x equals 5, then you'd see this value right there, that is the negative 3. That's how this works. So negative 2.5, where's that going to be? Well, let's see. Is x less than negative 3? No. Negative 2.5 is not less than negative 3. And it is not more than negative 2. So that means negative 2.5 actually does not exist in this function. It's not part of the domain because it's outside any of our what we could call parameters here. It's outside the domain restrictions that we're given. So that means there's a little gap right in here where negative 2.5 is, and there is no graph. All right, so that's how you do the evaluating of these piecewise functions. Second, now we're going to graph them. So let's start off with this first piece. Don't even worry about the x is less than or equal to negative 2. Let's just graph this first piece, negative x minus 3. So let's see here. We're going to go down to the 1, 2, 3 y-intercept, and then we're going to sketch a graph where the slope is negative 1. So I'll put some other dots here and some dots here. And just kind of think, and by the way, you should be using a pencil. If you're using a pen, this is not going to work out for you because you have to get rid of some of this. We're going to erase it. So do this lightly, very lightly. The thing I'm drawing, just kind of barely sketch with your pencil. Make it very, very light. Okay, so this is our first piece. Now this parameter says that the domain can only be less than or equal to negative 2. So if in fact, I'm going to have some little animation here. I'm going to have a window come up here. Now, if you'll look, we're only looking at this boundary of negative 2, which is going to be right here, and then you're only looking left of that. So that's clear. This is where the graph should exist. So what we'll do here is let's go over to negative 2 and put a dot here that's filled in, and we need to get rid of the rest. So erase everything else. And so the way we start off really learning how to do these is to think about the entire graph, but then this is the window in which it's only showing up. It only exists when x is less than negative 2. It's a filled in circle because x is less than or equal to. All right, now let's do this one. 4. Well, what does that mean? It means y equals 4. Y equals 4 is just a flat line, a horizontal line, way up here. 1, 2, 3, 4, right up here. Okay, so again, remember you want to use, I won't put arrows on that. You want to use a pencil very lightly. If I knew how to draw straight with this thing, you want to use a pencil that's very light and then look at the window. So let's pull up the window here. You're only looking between negative 2, which is right here, and 1, which is right here. So between those two numbers, and so we can erase everything else. So we're going to erase to negative 2, erase everything that's past the number 1, and then is it open or closed? On the left side here, it is an open circle, and then let's try and make that more on the line y equals 4, and then the 1 is a closed circle because it's or equal to. All right, so there's our second piece, and then our third piece, 2x minus 5. So again, use your pencil, do this light. I'm going to go down here, 1, 2, 3, 4, 5, put a dot, sketch my line, up 2 over 1, up 2 over 1. Now, I can see it's only going to be x is greater than 1, so I only need to, I'm having a hard time with this. Let me do that line again. There we go, something like that. And x is greater than 1, so if we look at the window is from 1 and on, so this is going to be our open circle. Let me erase everything that we don't need, and then right there at x is 1, we can have an open circle right there, and the graph takes off from there. Okay, that's how we do these. You want to think about what does the entire graph look like, and then get rid of anything that's not needed. Let's do another example that's beyond just lines. We're now going to do some parabolas here, and then this one will be a line. So let's start off with the vertex. Negative 1, 7. Negative 1, up 7, 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, 5, 6, 7, way up here. And we're going to graph. Remember, you should be doing this lightly with a pencil. Just sketch it light. Let's get some other points. Here's our other points, here and here. I'm using what's called the 1, 3, 5 method. I'm going to go down 1, and then I'm going to go down 1, 2, 3, and I'll reflect that point over here. And then I could go down another 5. 1, 2, 3, 4, 5. That's how I'm doing this fast. You could also plug in some coordinate points to be able to figure out where this parabola is. All right, so if I'm sketching this whole thing, you'd be doing something like this. Going down. Now we only want this graph to exist when x is less than 2. So we have to come out here to this x equals 2 value, and then it's only going to exist left of that. So everything else, let's erase all this stuff. We can erase everything that is to the right of that. Now is this exactly on that line? Let's see, x is less than 2, so it's going to be open. Well, we could figure out exactly where it is by plugging in a 2. Let's figure out where that hole is. 2 plus 1 is 3. 3 squared is 9. So I've got a 9, and then there's a minus in front, plus 7. What is that? That's going to equal negative 2. So if I were to graph this correctly, oh, I did have that point down there earlier. That's where it should be going. So I kind of messed up on my graph a little bit there. Let's plug that point back in, and it's going to that point there. Okay, and there's the left piece that's less than 2. Now we have a jump. We're going to go all the way out to x is greater than 4. Let's graph it first. Negative 1/3 x. Very lightly with your pencil, we're going to have a y-intercept of 0 right here, and then we're going to have a negative 1/3. So we're going to go down 1, 1, 2, 3, and over. And then down 1 and 1, 2, 3, over. Okay, so your line is going to look something like this. If I connected the whole thing, I could, but I already know that x can only be greater than 4. So I'm going to go out here, 1, 2, 3, 4, and it's going to be an open circle right there. So let's try to make this exact. Where exactly is that hole? Well, let's figure out where h of 4 is. H of 4 is, let's plug it into the line, and you get negative 4/3. So about negative 1 1/3, which looks pretty close to what that is. Let's clean that up, make it an obvious open circle. So 1, 2, 3, 4, and about 1/3. So something like that. Okay, there you go. There's that piece. Next up, you're trying one on your own. So go ahead and pause this video now, which is important. Please don't skip this. Pause, try this one on your own, and I will have your answers show up here so you can see if you did it right. And here's our answer. You got this parabola over here that had a vertex at -3, -5. You've got this line at y equals -1. That's our second piece here. And then our last piece, when x is greater than 2, be careful there, it jumps from 1 to 2. So that's why there's a gap here. And so you have there that vertex at 4, +4, because that with a absolute value graph opening down. All right, so hopefully you got that one okay. Pause here and look at that one and sketch that out if you don't have that correct in your notes. Number 5. Now, here's the hard stuff. We're going to write an equation of this graph. So let's come up with, first, how many pieces are to this thing? I have 1, 2 pieces. So when you draw your bracket, this weird little squiggly bracket, drop big enough to contain 2 pieces. So let's take the left piece here. What is the equation of this line? You have to think about what it would look like if you just kept going and going and going and going. And so this can be kind of challenging. Let's looks like it's a y-intercept of 2, which it should be. If you're not sure, we've got we got a dot here, and we have a dot here. So you could always think about these coordinate points and figure out the exact slope. So the slope is going to be 1/2 is the slope, but it is negative. Be careful about that. A lot of times kids see, there's an arrow that goes up, so it's positive slope. No. Think about the entire line. What would the entire line be doing? Okay, now it looks like it's going through the number 2, but let's verify and just make sure. So I'm going to plug in a point here about this point, -2, 3. So I'm going to use a slope of -1/2 and a coordinate point of -2, 3, just to make sure that I get this line correct. So y minus 3 equals -1/2 times that by x plus 2. And then let's see here, y minus 3 equals -1/2 x minus 1, -1/2 plus 1. Add the 3 and you get 2. So y equals -1/2 x plus 2. All right. So I'm going to write that down on this. -1/2 x plus 2. This is not necessary. You don't actually have to write out the equation next to the piece, but I'm just doing that because sometimes you might find it helpful. So y equals -1/2 x plus 2, comma. What's our domain restriction? It's the x values that are less than or equal to, see this? All of the x values to the left of -1, so I put a -1 right here. Now let's do the second piece. This is a quadratic, so let's see here. It's opening up, that's simple enough. So a quantity squared, it's just going up 1. When we go over 1, we go up 1, so the a is a nice, easy 1. X, I'm moving right, so we do the opposite, -2, and then minus, because we're shifted down, 3. Quantity x minus 2 squared minus 3 when x is, so think about this, where does it start? The x value here is a 0, so it's x is greater than 0. Ooh, there's your pieces. 2 pieces with all the graphs. This is the final answer I'm looking for. Don't close it. There's no closing the bracket here. Don't do that. It's just open right there.